Our last example of combining 11.2 and 11.1 content. So look at this example here. I've got a bag with 10 marbles in it. 3 are red, 6 are blue, 1 is green. I'm going to randomly select some out of here and lay them in front of myself. So I have 2 questions to ask. What's the probability that I'm going to pull out 2 blues? And also as a separate calculation, the probability that if I pull out 3, they all happen to be red. Now in this example, I'm not asking about the number of permutations, because the order I pull these marbles out is not important. I'm simply grabbing out some marbles and looking at them. So I'm going to be using combination, because again, it doesn't matter what order I pulled them in. So let's talk about the number of different ways I can pull out, talking about this first example, 2 random marbles. Well, I have 10, of which I'm going to choose 2. In other words, the order doesn't matter. I'm not putting them in order, so I'm going to use the combination. Now, that by definition, this is 10 factorial divided by 8 factorial, and also divided by 2 factorial. Because remember, we have to allow for the fact that we can switch their orders around, so combinations will give me a smaller output. When I simplify this, this is going to be 10 times 9, there goes the 8 factorial, it's canceled out, divided by 2. And there's that 2 factorial, which is just 2. You could write 2 times 1 if you'd like. You can also, if you like, write 8 factorial here and here. So there's my 10 factorial, which is 10 times 9 times 8, and so on. 8 factorial, which is 8 times 7 times 6, and so on. 2 times 1, 2 factorial. They cancel. This is going to simplify to 45 different ways to pull out 2 marbles. And that's using this combination thing from section 1. Now, how many different ways can I choose to have 2 blue marbles? So out of my 6 blues, how many ways can I choose 2 of them? 6 choose 2. So it's 6 factorial divided by, in this case, 4 factorial, 2 factorial. Remember, we take their difference and then the number we picked for combinations. For permutations, we don't include that part. So this is going to be 6 times 5 times 4 times 3 and so on, divided by 4 factorial, which is 4 times 3 and so on, times 2 times 1. There's my 2 factorial. So the 4, 3, so on are going to cancel, and then I can simplify what's left. I'm left with 15. So the probability that I'm going to reach in the bag, choose 2 marbles in any order I like, and they both happen to be blue, would represent 15 out of 45, which reduces to 1/3, or 33%. In this case, I'm not interested in the order of the marbles coming out of the bag, so I'm using combinations. I'm still working on the fundamental principle of how many ways can it happen versus how many ways total does it happen. Let's wrap it up by talking about those red ones now. If you want, now's a good time to pause to make sure your notes are caught up. Oh, wait. Now that you're back, there's that. Let's talk about this probability that I pull out 3 red. So, I have 10 marbles in my bag. I'm going to randomly choose 3 because I've pulled out 3. So I'm working with a combination involving 3. So 10 factorial divided by 7 factorial, 3 factorial, which is 10 times 9 times 8 divided by, the 7 factorial will cancel out, 3 times 2 times 1. That's going to simplify to 5, let's see here, 5, 3, 50, boom, boom. So that's going to be 10 times 9 times 8 divided by 6, 120. Now as a note, remember with your calculator, many of them are not set up to evaluate this directly. You have to do some simplifying first because your calculator doesn't like dealing with really big factorials. So there are 120 different ways I can pull out 3 marbles and lay them in front of me in any random particular order. The next step on the line then is to say, all right, how many different ways can I pull out 3 that are all red? If I stay with this paradigm, 3 choose 3. How many different ways can I have 3 red marbles? Because that's ultimately what I'm looking for. Of all the different ways I can have 3 marbles pulled out of this bag, how many of those ways represent 3 red? So 3 red, put them in any order I like by picking 3 of them. Well, if I follow the rules, 3 factorial over 0 factorial 3 factorial, 0 factorial is just 1. 3 factorial divided by 3 factorial is 1. There's only one way I can have 3 red marbles. My result, probability there is going to be 1 over 120. There's one way to get 3 red marbles. Out of 120 different ways, I can pick 3 of them out of the entire bag. That probability I can then turn into a decimal. And we're not exactly talking something very likely. 0.008 or 0.8%, less than 1% of the time. The challenge, of course, is always in asking how many ways can these happen, because at this point the probability of themselves is just a fraction. So we have to go back to our ways of counting the possible outcomes. The other advantage we have here is if we're feeling a little stuck, you can always fall back on a little bit of art to help you. So for example, if I got my 10 marbles here, I can actually do 3 reds, 6 blues. Once you've got this in front of you, you can ask yourself, well, how many different ways can these things happen? Especially when we're looking at focusing in on things like just having 3 red. Well, there's really only one way I can pull them out. With the blues, on the other hand, we said there were more ways to do that. So I can say, well, I wanted to have 2 blues, so maybe I have this blue and that blue, or this blue and that blue, this blue and that blue, and I can start to kind of count some of the ways it can happen, get a ballpark figure to work with, so I'm not entirely reliant on my mathematics. You should always ask yourself, does my answer make sense? And as I said before, one of the most important things is how we count combinations, permutations, and the fundamental counting principle. All right, good luck.